So at this point in time, we've learned how to do a bunch of different things with rational expressions involving variables. We've learned how to simplify, multiply, divide, add, subtract. But we've never really had a situation where we had an equal sign involved with a problem like this. So now we're not only simplifying, we're going to be solving an equation involving rational expressions. Now, with this first problem here, this is a problem that if you guys really thought about it, you could probably work out. You would take the right side of the equal sign, maybe try to get a common denominator like we learned how to do, and the work for all that process would look something like what you see right here in red. So you basically get a common denominator, and once you have your common denominator, so you get your 3k squared, you could do a little cross multiplication. And you could get your pieces right there, and you can keep doing and do this whole process. It's going to work out just fine, eventually solving it. There is an easier way, though, when you have an equation. So if you want to work your way through this and see if it makes sense to you, that's fine. Pause the video. Try it out, and I didn't actually finish with the solutions here. We're going to get the same answer in an easier manner. So I'm going to get rid of all this stuff right here, maybe, and we'll take things from there. Okay. So basically, my rationale for doing this problem right here. This problem is really ugly looking because of my denominators. Right now, I have variables in my denominator, and that's bad. Those make the problem tougher to deal with. You have to get common denominators. Really, the fractions in general are just an annoyance to us. So what I'm going to do is think of something clever that I can multiply my entire equation by that's going to kill off all three of my denominators at once. Just wipe them all out. So I need to think of something that 6k squared, 3k squared, and k all go into. For example, if I said, well, I'm going to multiply everything by a k, that would be good because it would kill off this one, cancel that out. But if you multiply this guy by k, that's not going to go away. You're still going to have a denominator. So the trick is figuring out something that all three of those pieces go into. And after you think about it for a little bit, you'll come up with the answer, or hopefully you come up with the answer, 6k squared. So what I'm going to do, all three of those things go in there. I'm going to distribute my 6k squared to all three parts. On the left side, things are great, because I get 6k squared times 1, which is just 6k squared. And when I divide by 6k squared, that just goes away. That whole thing turns into 1. I get something divided by itself. Perfect. When I do my second guy right here, 6k squared, I'll put it up here so it's easy to see, over 3k squared is going to get me, the k squareds will cancel. I'm going to get just a 2 from that one. And when I do my last equation right here, I have 6k squared over k. Well, 6k squared over k is going to be one of the k's will cancel. You'll just get minus 6k. So you distribute it all the way across. The red equation is what you're left off with. Now, I don't know about you guys, but I think that red equation looks a lot easier to solve than the original blue. It also looks easier than the original problem I had, the long way you could have worked it out. Now it's just basically a matter of solving for x. You subtract your 2, etc. And when you do that, you're going to get k equals 1/6. And that's our answer to the problem. Done. The one thing we have to watch out for in these problems here is we need to make sure we have restrictions on what numbers we can't use for k. We have to make sure that that number we got, the 1/6, is not a restricted value. Then we would have extraneous solutions. On our original problem, the really only issue we have for k, we would have to say k cannot equal 0. 1/6 is clearly not the same thing as 0, so we are good. If we would have gotten the answer k equals 0, that would have been a problem. Then we would say, extraneous solution. But we're good. 1/6 is our answer. On a second problem right here, looking at this example, it looks really intense. There's a lot going on. So go ahead and copy this one down, and maybe if you're feeling good, you can try it out already. But what strikes me is two things. First of all, I think it would be helpful to factor this. And second of all, it's really kind of dumb that they wrote this part over here and that second term like that. Who does that? That doesn't make sense. So I'm going to do two things. I'm going to write this as 5 over, if you do your magic numbers. This will be x minus 4 times x minus 3. On my second guy right here, this will turn into negative x plus 3. And I'm actually going to go ahead and pull out a negative 1. So you get negative 1, and then it'll be x minus 3. And from there, I have minus, and there's a negative right there. I'm just going to turn this into plus 2 over, it'll be x minus 3. If that step is a little fuzzy with what I did there, just take a look at the steps. Again, I switched it around, right? Switched it around, pulled out a negative 1, and my negative canceled with my minus sign up here and made a regular plus. So anyway, after I do that, I have equals, and that's what I'm going to leave alone for right now. So I need to think of something I can multiply by that's going to wipe out all of my denominators at once and give me a much easier problem to do. Well, on my problem right here, it's clear that if I multiply by an x minus 4, for example, this last guy on the end, the one I just put the black parentheses around, is going to go away. But x minus 4 isn't going to kill off my middle guy here, and it's not going to do everything. It's going to take out part of this one, but it wouldn't take out the whole thing. What I need to do to cancel out my denominators is actually pack in both of those parts. So this is going to look kind of intense, but I'm going to multiply both equations by x minus 4 and x minus 3. I realize that those two pieces are going to wipe out everything I need. So when I distribute here, I am going to take it to all three parts in my problem, distribute it all the way across. On the far left side, these are just going to cancel. I'll undo that part, but you can see when you multiply that right there, those are going to go away. Maybe I better write it on there. So I'll actually put it on the top part here. When I distribute to my first guy, I get x minus 4, x minus 3 right here with the 5. Well, those just cancel. All that's left on my first guy is 5. When you distribute to your second guy, you're going to get, again, an x minus 4, x minus 3 on here. And the x minus 3's will cancel, so I just get plus 2, and I have the x minus 4 left over. And when I distribute to my third guy right here, the x minus 4's are going to cancel, so I'll just get 5 x minus 3. And again, I think that red problem right there looks a lot easier to solve than your blue or your purple. So really it's just a matter of cranking out the algebra from here on out. You get 5 plus 2x minus 8 equals 5x minus 15. And let's see, if you go on and solve that, you're going to get, it's a negative 3 right there, so you're going to get 3x equals 12. You end up getting 4 for your answer. Looks pretty good. Now, don't forget, we have to do our restrictions on this problem. What numbers can x not be? What would have been bad for x that we would divide by 0? And it turns out from right here and right here, those are the easiest places to see it. The bad numbers for x, we say x can't equal 3 and x can't equal 4. Well, this is bad news for us because we got our answer, x equals 4 right here. That can't happen because we said that number's not allowed. We call that an extraneous solution. We've talked about those before. If the answer you get is an answer you excluded, we say it's extraneous. Doesn't actually work. So this problem actually has no solutions to it. Even though we got an answer, it was in our restrictions, that means it's extraneous. All right, gonna check my time here, see if I should break off into a new video or just keep going with this. I'm gonna go ahead and do one more problem in this video. It'll be a little bit longer video, I apologize. But third problem, just to make sure you've got the idea down. So maybe if you wanted to on this problem, you could even pause the video and try it out for yourself first. But I'm gonna go ahead and work my way through it here and show you guys what's going on. We wanna kill off all of our denominators at once, have a much easier problem to do. And in order to do that, we're going to need to multiply by x plus 1 and x minus 2. Basically, you pack up your denominators and you're going to distribute it everywhere. So when I do that to my first guy, let's see, I'll switch to purple for this. If I put my x plus 1 and my x minus 2 up here, x plus 1s are going to cancel. We're just going to get x and x minus 2 left over. When I do it to my second guy, distributing, x minus 2s are going to cancel. I'm just going to plus x times x plus 1. And when I do it over here to the third side, neither part cancels, unfortunately, so I have to leave them alone. So it looks like that. Now, that's a problem you guys should be able to solve. That's a quadratic. It'll end up being, but you just distribute, you solve like we've been taught. So when we go through and do our math here, that's going to be 2 times x squared minus x minus 2 when you do your FOIL. Yeah, that's right. So then we're going to get 2x squared minus 2x minus 4 over here. And on this side, 2x squared minus x. You combine like terms. So I just combined my like terms, did my FOIL, and so on. Now, we actually lucked out on this problem. It worked out nicely because look what's going to happen. Your 2x squared, when you subtract from both sides, will cancel. That's good. That means we don't have to do a quadratic problem. If it was, you might have stuck up a new quadratic formula or something like that, but it's something you can definitely handle. Sometimes you'll have quadratics. Luckily, they cancel in this one. We end up with x equals -4. So if we look at our restrictions on this problem, the numbers that would have been bad for x in the original, we would have had x can't equal -1, and x can't equal 2. So we are good with our -4. That was not in the restrictions, and that is our answer. So blasting the fraction is a really good method to use to cancel out our denominators and solve a problem nicely.